So we have a formula for expectation. Doesn't that look nice? As far as things in that formula are, this symbol is a Greek letter. It's one of my favorite Greek letters. It's the Greek letter mu. Sort of looks kind of like an M and kind of like a U, and you say mu. It's like very cool. So that's why I like that. And it is a symbol that's often used for mean or average. So your expectation is what you would get on average. Kind of makes sense. Now the formula here says if you have a probability distribution chart, you're going to add up all of your items. So in our probability distribution chart, where we have a number of different items, and this is x, and this is probability x equals x, this x would be these numbers, like 0, 1, and 2. And that gets multiplied by each of their probabilities. So if 0 happened, let's use our flipping the coin, 1 out of 4, 2 out of 4, 1 out of 4. Your chances of getting 0, when you put in 0 here, you go 0 times 1 out of 4. This symbol here is the symbol for adding things up. So you go through each of the possibilities, multiply them together, and add them up. So you'd have 0 times 1 out of 4 plus 1 times 2 out of 4 plus 2 times 1 out of 4. That's what the formula says. If you flip a coin twice, what would you expect to get? How many heads would you expect to get? What do you think the average would be? So if you think about it, if I flip a coin twice, what do you think on average? How many heads will I get? 1? So if we look at this and actually add it up, this will be 0 plus 2 out of 4 plus 2 out of 4. And sure enough, you're right. What you would think is what actually comes up with the formula, is that on average you will get 1 head. That's your expectation. If you were to flip that coin 10 times, on average you probably expect to get 5 heads. So it's not based only on the values we have, but on the probabilities of each of those values. So here we have a probability distribution chart. We're going to find the mean. That's our expectation. We're going to find the median. Do you remember median, mode, and statistics? Have you heard of those words before in English? The median is the one that happens right in the middle. So if I'm looking at our class average, the computer will tell me class average in this class is 78.2%. And the way that that's figured out is by adding up everybody's scores and dividing by how many people are in here. On my computer, it will also tell me the median. The class average is 78.2%. The median is 70. What the median means is half the people in the class have 70 or higher, half the people in the class have 70 or lower. So it's a different way of making a measurement. It's a way of separating the group into two. Sometimes the median is a better way to look at an average than the actual average. For example, the actual average of a class might not be good to use if everybody has 95% in the class and 3 people have never come and have 0. And I look at my class average is 68% or something like that. Someone says, oh, you don't have a very strong class. Class average is 68%. Well, if you took out those 3 that never showed up and have zeros, all of a sudden your class average is way back up at 95. So if you looked at the median in that group might be 95. Half the people are above 95. That's very good. So depending on which average you're looking at can give you different information about the data. And the mode is the one that happens the most. So the mode might be important to know is if you go, oh, I'm going to work at McDonald's. I hear that on average, their average salary is $200,000 a year. That just so in Winnipeg. Now, it just so happens in Winnipeg, the CEO of McDonald's lives in Winnipeg, and he's making $10 billion a year, which, if you look at their actual average of the people working at McDonald's in Winnipeg, bumps that average way up. When you look at the mode, it's $11 an hour. Is that minimum wage right now? Is it bumped up again? Is it 11? 11.50? 11? It's 11.50 rounded down. So if you look at the mode, there's like, yeah, the average of a McDonald's salary since the CEO lives in Winnipeg is $200,000 a year, but the mode is $11 an hour, which means that that's what, if you go to work there, that's probably what you're going to make. So with this, how do we use a probability distribution chart to find these things? Well, the mean is your expected value. So we can use our formula to figure that out. The formula says add up each one multiplied by its probability. So we would take 1 times 1/10 plus 2 times 2/10. There's a typo here. This is supposed to be a 3. Plus 3 times 3/10 plus 4 times 4/10. And if you multiply all of those together, we'll get 1/10 plus 4/10 plus 9/10 plus 16/10, 25, 29, 30. So your expected value, your average, is going to be 3. What you can do with data like this, since all of our probabilities are out of 10, if you would like to create an actual situation where this happens, we could list 10 items. Does this make sense? If I have 10 items and I have 1 1, 2 2s, 3 3s, and 4 4s, can you see that there's 10 items in total? I have 4 3s. Yes, that is an issue. There we go. Perfect. 3 3s, 4 4s. If we add them up, there's 10 things. Good. Your chance of getting a 1 is 1 out of 10. If you pick 1 at random, your chance of getting a 2 is 2 out of 10. 3 is 3 out of 10, and 4 is 4 out of 10. Okay? If you wanted to find the average of those, if those were your last 10 test scores, you got 1% once, 2% twice, and so on. If you wanted to figure out your average in that class, you could add up all those numbers, 1 plus 2 plus 2 plus 3 plus 3 plus 3. Add them all up, it adds up to 30. Divide by 10, because there's 10 items, you would get 3. Same thing happens with our formula. Our formula has the probabilities built in, but we could think of an actual example to see that. The median is what separates the top half from the bottom half. So when you have an even number like we have right here, if you wanted to split this in half, half would happen right there. Can you see that there's 5 scores above, 5 scores below? If you have an odd number, if we added one more number, say you really studied for the next test and you got a 5, then you would have a middle number that's actually the 3. Okay? So when there's an odd number, like I added the 5, then the median would be 3. Since there was an even number, and I take away those, the median will be whatever the average of those two numbers are. They're both 3s. So in this case, our median will be 3. That's how you can find a median if you have an actual list of data. If you're looking at the probability distribution chart and you don't want to make a list of data because your numbers were all out of 72 or something and you don't want to write 72 things down, to find the middle. Can you see after 1, we're done 10% here. And once we're done 2, if we add those up, we're at 30% of the data. And then we're at 60% here, and this will be always 100% at the end. If you're looking for the 50th percentile, the median, right in the middle, where does that 50th percentile happen? Right here, between the 0.3 and the 0.6. So your median would be 0.3. If you were doing this method and this happened to have been 0.5 right there, then your median would be between 2 and 3, and your median would be 2.5. But in our case, our 0.5 happens between somewhere in the 3, so we can say that our median is 3. And finally, which one do you think happens the most? That one's the easiest. Most probable is the 4, since that happens 4 out of 10 times.